Okay, so today's video is going to be how to prove triangles are congruent, and then how do you write a congruence statement. So make sure you have those two down in your notes. The first thing we're going to do is review the ways that we talked about in class how to prove triangles are congruent. So what combination of congruent sides and angles always make congruent triangles? So our first one was side, side, side. We also had side, angle, side. We had angle, side, angle. We had angle, angle, side. And we had hypotenuse leg for right triangles. The ones that did not make congruent triangles were angle, angle, angle. They made different sizes. And side, side, angle. So those two do not make congruent triangles. So we're going to kind of look at the pictures here that we have. So the first one we're going to talk about is side, side, side. If you are given all three sides of each triangle and they are all congruent, then you are going to have congruent triangles. So you can see the picture at the bottom left where all three sides are given congruent. And you can see the picture on the right where only two sides are congruent. So you have to assume that this middle side is congruent to itself. So if this was AB, you could say that AB is congruent to AB by the reflexive property. So these would be congruent. The next one, side, angle, side, where that angle is in between the two given sides that are congruent. So in the first picture over here, you can kind of see that it was a right angle between them. And then this second picture, you can see that I've already marked these angles. These are vertical angles. So you can see that it's side, angle, side in order. And then the bottom picture kind of shows you separate, but not a right angle. The third one is angle, side, angle, where the side is in between. So in this first picture, you can see that it's an angle, the side, and then the angle in order, where the angle is adjacent to the side in the middle. This second picture over here, we have two angles, but then we have this side in the middle. So we have to assume that that side is congruent to itself. So I could call it YZ. So I would say YZ is congruent to YZ by the reflexive property. That one's going to come up a lot. And then in the bottom left, you can see angle, side, angle again. Just another way that you could see angle, side, angle. The next one is angle, angle, side. So two angles and then the next side, the next adjacent side. So you can see that we've got one angle here, the second angle here, and then the side is actually connected to this second angle. So it couldn't be this side out here. Then on the right, again, we have another reflexive. So anytime you see the two triangles sharing a side, so if this is maybe MN, you would say MN congruent to MN by reflexive property. So angle, angle, side there, and then another picture here down on the bottom left. And then the last one here we have is a hypotenuse leg. It's pretty self-explanatory. It only works for right triangles. So this one looks like we actually have two sides and an angle, which would be side, side, angle, but we cannot use side, side, angle. So since it is a right triangle, we can call it hypotenuse leg. So that's the only one that works that way. So we've got we have 7 examples to go through. So we're going to start with the first one. I am going to try and color code the different information to the picture. So the first thing that I'm going to mark is angle 1 congruent to angle 2. So I'm just going to mark that with arcs on my picture, angle 1 congruent to angle 2. And then I'm going to show angle A is congruent to angle E, but at this time I'm going to use the double arc because I've already used a single arc. And then the last thing that I'm going to show is that segment AC is congruent to EC with a tick mark. And then when I look at my picture, I can see angle, side, angle. So angle, side angle is our way that we are proving that these two triangles are congruent. So on to number 2. The information that you are given for number 2 is that side AB is congruent to BC. So I'm going to mark that. You are also given that AD is congruent to CD. So I'm going to mark that with the double tick marks. And then I have to make an assumption here, or an inference, that BD is congruent to itself, and that is due to the reflexive property. So I'm going to put BD congruent to BD, and this is by reflexive property. So I can look at this picture and I can see that I have a side, and a side. So that's going to be side, side, side. Okay, the third one, we are given that we have a quadrilateral, and it says that PR is congruent to ST. So PR and ST are congruent. And then it says that angle PRT is congruent to angle STR, so I'm marking those two. And then I'm going to use my reflexive property again right here, and I'm going to say that RT is congruent to RT by reflexive property. We're going to use that one a lot. So I can see I have a side, an angle, and a side, so this is going to be side, angle, side. Okay, for the fourth one, getting a little bit harder to see in our picture here. So I'm going to show that MO is congruent to QP, MO and QP. Then I'm going to show that angle M is congruent to angle Q. Now in this picture, it's kind of hard to see, but if you were to separate the two pictures, you could see that they both share the side OP. So OP is actually congruent to OP by the reflexive property. And so I have a side, and an angle, which when we're trying to prove triangles congruence, we cannot use side, side, angle. So this one is not possible. Okay, number 5. I'm given quadrilateral PQRS, and it says that PQ is perpendicular to QR, so that's this one right here. And PS is perpendicular to SR, which is right here. Then we are given that QR is congruent to SR, so that's these two down here. Mark those with a tick mark. And again, they're sharing that side, so PR is congruent to PR by reflexive property. So when we look at our picture, I have side, side, angle, which is not a way to prove triangles are congruent, but this is a right triangle, so I actually have hypotenuse leg. Hypotenuse leg for this one since it is a right triangle. Okay, number 6. The first information that they give me is that LS and MT intersect at point P, okay? And then angle M is congruent to angle T, so I'm going to go ahead and mark that. And then angle L is congruent to angle S, and I'm going to use the double arcs. And since I do have the intersection of those two lines, I have vertical angles there. But that doesn't help me because I have an angle, and an angle, and I cannot use angle, angle to prove that triangles are congruent. So this one is not possible. So moving on to the last one, number 7. It's telling you that the segment KT is bisecting the angle IKE and angle ITE. So I'm going to go ahead and mark that on my picture. When it says that the segment KT is bisecting the angle, that means it's cutting it into 2 equal pieces. So I'm going to mark that one over there and then these two over here. And then again, they're sharing that side here, KT. So KT is congruent to KT by reflexive property. So when I look at my picture, I've got an angle, a side, and an angle. So it's going to be angle, side, angle. Okay, in the next part, we're going to talk about what is a congruent statement and then what information you can get from a congruent statement. So a congruent statement is just saying something is congruent to something else. So you could say triangle ABC is congruent to triangle DEF. So you could talk about triangles. You could talk about segments. You could say segment AB is congruent to segment DE. Or you could say angles are congruent. So I could say angle A is congruent to angle D. Or you could use 3 letters. Angle ABC is congruent to angle DEF. So a congruent statement is just saying things are congruent. So then we're going to answer our question, what information can I get from a congruent statement? So when you're looking at a congruent statement, like this one given here, triangle ABC is congruent to triangle EFG, I can see that A is congruent to E. I can see that B is congruent to F, and I can also see that C is congruent to G. So when I want to write things that are congruent, I could write angle A is congruent to angle E, or I could write angle B is congruent to angle F, and then angle C congruent to angle G. You can also write segments that are congruent. So in this picture, or in this statement, AB is congruent to EF. So I could say segment AB is congruent to segment EF. Even without looking at the 2 triangles, I know which parts correspond, so I know which ones are congruent. So I could continue and say BC, I could say BC is congruent to FG, and then I could say segment CA is congruent to GE. So I can get all that information just from one congruence statement. But notice that they're all in order. A is always corresponding to E, B is always corresponding to F, and C is always corresponding to G. The order matters, so make sure that you are writing in the correct order. So we've got one last example to do. We're going to figure out if these triangles are congruent, and then if so, we're going to figure out how they are congruent. So you're given some information. So you are given that AC is congruent to EC. You are also given that BC is congruent to DC. So that was our given information. 2 sides are congruent, and they were marked with tick marks for us. Our next piece of information that we're going to use is vertical angles right here. And we're going to say angle ACB is congruent to angle ECD. So notice I started with angle A in my first part of my statement. So when I started the next part of my statement, I had to start with angle E because angle A is congruent to angle E. So I had to go in order. And this came from vertical angles. So when I look at my picture, I can see I have a side, an angle, and a side. So if I wanted to say that these were congruent, I would have to use side, angle, side. So I'm going to go ahead and write my congruent statement of the triangle. So I'm going to say triangle ABC is congruent to triangle EDC. Notice everything matches up. Angle A, angle E, angle B, angle D, angle C, and angle C. So I would say that that is congruent by, and we already looked, side, angle, side, and that would be my reasoning. That's the last example for these notes, so make sure you have these for the next class.